Hey, hi, it's Miss R Squares Up with Math. Today we're squaring up with like terms. Cool. Let's first start with what are terms? Let's get into that. Terms could be a number, it could be a variable, it could be a number and a variable together. I'm going to write that out. So it could be a number, it could be a variable, it could be a number and a variable together. So these are examples of terms. Each one of these is one term. Do we get that? So let's say I write something like this. This whole thing is called an expression. However, if I just isolated the 5, that is one term. If I isolated the 2y, that is one term. So just let you know, one term is only one part of your expression or your math sentence, your equation. Doesn't matter. It's only one part, one term. Cool. Let's move on. Let's see. Let's do some example of like terms. Now, like terms are terms that have the same variable and or the same exponent. With that being said, I'm going to show you examples of like terms. Let's say 5 and 3. They are from the same family, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They are all from the same family. They're from the same family, meaning those like terms can be combined by adding, subtracting, multiplying. I'll do a dot for multiplying, and division. So if they're like terms, you can do any of those to it. If they're like terms, again, you can do any of these to it if they're like terms. So 2x and 3x, they are from the same family. They both have x as a variable. They both have just one little regular old number, or even if it was 10x, it'll be the same. Has a number there and the same variable. Now, let's say 2x to the second power and 5x to the second power. These are like terms because not only do they have the same variable, but they also have the same exponent. They're part of the same family. Now, if I gave you 2x and 2x to the second power, these are not like terms. They are not part of the same family. Do you see an exponent up here? No. Do you see an exponent up here? Yes. Do they match? No. No, they do not. Let's say I gave you 2x to the second power and 2x to the third power. Are these like terms? No, they are not like terms. They're not part of the same family. Do we see an exponent here? Yes. What number is it? 2. Do we see an exponent here? Yes. What number is it? 3. Do these equal each other? So they're not like terms. So, moving on. Let's erase that bit right there and scroll down. Now, if we want to combine like terms, let's say we're combining like terms. Let's say we're doing 5 plus 3. We could do that. We're doing 2x plus 3x. We can do that. Let's say we're doing 2y plus 2x. We cannot do that. Cannot do that. That's not possible. This equals check. This equals check. We cannot do this. They are not like terms. We cannot do it. Let's say we do 2y times 2. Can we do that? Yes. I am going to tell you why. So, when you are multiplying or dividing non-like terms, you can combine them. You can combine them. So think of it. If I do 2y plus 2, this is not possible. I can't force myself to add on. I can't force myself to add on non-like terms. However, I can force myself to multiply these two. I could do that. I could do divided by 2. I cannot do 2y plus 2 or 2y minus 2. So just know that rule. If they are like terms, you can do any of the operations, any of them. You can do plus, minus, multiplication, division, blah, blah, blah. If they are not like terms, the only thing you can do with non-like terms is multiply and divide. That's the only thing you can do if they do not match, if they're not part of the same family. Only thing you do is multiply. Again, you can't add it. They're not part of the same family. You can't subtract it because they're not part of the same family. However, you can multiply it. You can double it. You can triple it, and so on and so on. You can divide it, but you cannot add or subtract it. So let's keep that in mind. I like to say this rule to remember. If the variable or the exponent is different, the terms are not like terms. Again, if the variable or exponent is different, they are not like terms. I say that over and over in my head, so I know. They are not like terms. Cool. So if I want to combine like terms, let's try combining some. Let's actually do it. Let's say I want to do 3x plus 4x. When you do 3x plus 4x, you have to make sure you know that, are these like terms? Do they look the same? Yes, they do. So if these are like terms, what can I do to them? Can I only multiply and divide? No. They're like terms, so you can do all the above. All the above. So I can add them. When you are adding 3x plus 4x, think of 3 plus 4. So what's 3 plus 4? 7. Cool. I can't just do 3 plus 4 equals 7 because remember, we have this x here. We have this x here. So what I'm going to do, add that x there. So if you are confused with that, just think of 3 plus 4, add the x at the end. Or some people like to say, okay, I have 3 x's. If I add 4 x's to it, how many x's do I have? Again, they look at this problem like this. If I had 3 x's, right? And I want to add 4 x's. And I'm adding these two together. How many x's do I have? Okay, so if need be, you can think of it like that. Okay? Cool. So let's say we want to do a subtraction problem. Let's do a quick subtraction. I want to do 10y minus 6y. Okay, first we have to identify, are these like terms? Are these like terms? Let's see. They both have a little number in front. Yeah, number in front. Okay. And it doesn't say anything with that number. I don't see anything different with the number. They're both regular old numbers. Okay, cool. Move on. They have the same variable. So are they in the same family? Yes, they are. So that means I can just do this like normal. 10y minus 6y. You have 10 y's basically. And you're taking away 6 y's. What do you get? Exactly. 4y. Now, I am going to do an example of just a regular one. A regular one without a variable, which is just basic addition or subtraction. As in 5 plus 3. Okay, you ask yourself, are these like terms? Yes, they are. So I'm just going to add it up. Are these like terms? Yes, they are. So I'm just going to add them up. So what you're doing with like terms is you're just asking yourself, are they part of the same family? Yes or no? If they are, okay, you can add, minus, multiply, divide. If they aren't, you can only multiply or divide them. Moving on. Let's say I want to combine 3x plus 5. I first have to ask myself, are these like terms? No, because one has a variable and one does not. One has a variable and this one does not. Where's the variable? We don't have one. Let's say it did have a variable. Let's say it had y. Do these match? Does x match with y? No, it does not. Let's say this did have a variable of x. Would they now be like terms? Yes, they would. However, it didn't have a variable. So, therefore, that's all we could do. That's all we could do. If you see this on a test and I tell you to solve for it, just know you can't. You can't. Unless I actually give you 3x plus 5 equals, I don't know, 15 or something along those lines. And then I tell you to solve for it. But if I don't give you anything on this side, don't fall for my tricks. Do not fall for my tricks. Cool. So, common mistakes to avoid. Adding x and y Okay, so I get this a lot. Where people are adding x and y because they literally think because it's x and y together in the alphabet, they do it. But no, don't do it. Don't overthink. Do not overthink. Stop right there. Don't overthink. Now, adding x and x to the second power. They are not part of the same family. Do you see an exponent there? No. Just think of it like that. Do you see an exponent there? Yes, we do. Does this one have the same exponent? Oops. Does this one have the same exponent as this one? No. So don't do it. Don't do it. Please avoid these. Cool. Also, another common mistake is changing the variable when you add. For example, if I do 2x plus 2x, don't magically get 4y. No, 4x. Do not change the variable. Do not change the variable. Where do we get y from? Y is not part of it. Y is not part of it. These are x's. Y is not part of it. Do not overthink. Do not do it. Do not do it. So, I want you to try this one alone. Okay, so I'm going to give you a moment. I want to ask you, are these like terms, yes or no? And I want you to answer in your head, answer out loud. And I'll give you a second. Okay, so are these like terms? Let's look at it. We have a number right here. Cool, a number right here. We have the same variable. We have the same variable. These are part of the same family. I know you see a negative in front of a 7a. Do not overthink it. Do not overthink it. This 2a does not need to have a negative in front of it in order for it to match. That does not matter. We are looking at these right here. These right here. That's what really matters when it comes down to it. Now, okay, I'm going to ask you, are these, let's see, let's do this one. Are these like terms? I'm going to give you a second. Okay, if you said no, you are correct. No. No like. No like terms. No like terms. Yes, like terms. No like terms. No like terms. Because, yes, we have a number here. We have a number here. Yes, we have the same variable. But do we have an exponent here? Yes. Do we have an exponent here? No. If let's say we had cubed here, or m to the power 3 is what most say. Let's say we had that there. Would they still be like terms? Or still not be like terms? They will still not be like terms because it's not the same variable. But again, looking at our original says 4m and 4m squared, or aka 4m to the second power. I don't see this here, so they're not like terms. Okay, so do not overthink. Do not overthink. So reminder, ask yourself, does the variables match? Do the exponents match? If yes, combine. If no, leave it alone. And that's all you need with like terms. Now, if you want a more detailed, just let me know in the comments below. I did do this one a little bit quicker because some people were saying that they would like it to be more condensed. So I tried it. But if you would love a more detailed one where I can actually get into it, let me know. And I shall see you next time.